Orbax here for another episode of Real or Unreal, where today we're exploring food production off-planet. And joining us is Professor Mike Dixon from the Controlled Environment System Research Facility here at the University of Guelph. So we can travel throughout the solar system, but we can't always bring a lunch bag with us. Will we be able to grow food on Mars?
We have to, and we're developing the technologies here to do exactly that, creating enough food for astronauts to explore Mars, find life, which is the plan. But food determines how far from Earth we can go and how long we can stay. So we have to figure this out, and this kind of research activity is exactly what we're up to.
Mike, what is the power of plants in space?
Well, food, as I told you, drives the equation. So we can eat them. They give us oxygen with photosynthesis. They consume our carbon dioxide, and they recycle fresh water. And they make us feel good. So a little bit of hort therapy thrown in there. Virtually everything we do here is pulled by that technical challenge to go to Mars and grow food for human life support. Everything. There are lots of technical challenges, but since we're not going to Mars yet, almost all of the technologies we develop end up as servicing terrestrial agri-food, so agriculture on Earth. Especially harsh environments like the north of Canada or the deserts of the Middle East, places where food security is an issue. The technologies we develop here to grow food on the Moon and Mars is exactly what's required to grow food in a snowbank in Yellowknife.
Yeah, is there any specific science that you do here that we can point to that benefits us here, but also would be going forward into the universe?
Well, you see all these LED lights behind us here, and you'll see some different colors around the project. We've learned that the different color of light creates different chemistry inside the plant, and that creates different taste, different colors, different medicinal compounds, profiles, and that's helping us solve one of the key issues in plants for medicine, for example, or nutrition. We can standardize the profiles of nutritional or medicinal compounds.
What parallel means of producing food do we have? You know, we can grow food, but will we ever see the equivalent of like a Star Trek replicator? Will we be able to 3D print food when we're up there?
Absolutely. I think we can do it now, can't we? There's the veggie burgers and those sorts of things. And basically, all you have to do is put the right chemistry together in a tube.
So inside this controlled environment, what variables are we working with to produce food in space?
So light color is a new kid for us, and we've learned a lot with that. But light, CO2, temperature, humidity, nutrients, and water, and those are in the root zone. And very, what I call high fidelity, so really precise, tight control over those gives us the predictability of the outcome.
I mean, the whole point of this series is exploring pop culture and where the science is in that. Based on your experience in the sci-fi universe and the movies that you've seen, who gets it right? Where are we looking that's the closest representation to off-world food?
The closest scientifically accurate sci-fi movie in recent years has been The Martian. So that arithmetic that Matt Damon was doing with his potatoes, that's exactly what we do here. We predict the nutritional composition of a range of food crops in a menu that's preset, and that'll determine how long you can live. And like I said, food drives the equation. So he was doing exactly what he had to do to determine how long he could survive on Mars.
So it turns out in The Martian, the science is more real than unreal.
Yeah.
Straight from the Matt Damon of the University of Guelph, Professor Mike Dixon himself.